Okay. Good afternoon. We are looking at the Pom Assignment review, the one that is due on 15th September 2024. The first question of this assignment was on inventory management. Okay. So this inventory management question reads, Dream Resorts makes wine which it bottles and sells in its own location, that is restaurant and wine shop. It costs 1,100 to set up, which is brew and bottle a batch of the wine. The annual cost to store the wine is 2.75 per bottle. Then the annual demand for the wine is 16,000 bottles, and the winery has a capacity to produce 28,000 bottles annually. The current production policy is to continue producing the wine until the storage gets full. Okay. The storage holds a maximum of 750 bottles of wine. Production starts again when the inventory of the wine is depleted. Assume 1 year is 365 days. So required, the owners of the Dream Resorts are considering an opinion, okay, or that is an option of increasing the wine storage space to hold a maximum of 3,000 bottles as part of their expansion strategy for the 5 years. Is this a good option in terms of cost saving, be quantitative? Okay, so we can now get down to write the solution. This one, the days of the year 360 days, that is 365 days. And of course, the annual demand is 16,000 bottles. The holding cost or carrying cost is 2.75. Okay. And then the setup cost is 1,100. Annual production is 28,000 bottles. Then current production policy, storage of 750 bottles, that's maximum. So we need to find what our Q is using a maximum inventory formula. P minus D, this is the daily production minus daily demand, then multiplied by Q over P. Q is the economic load size or production size. Okay. So we need to find, it makes the subject, so daily production, so annual production over days of the year, which is 76.7 bottles. Then we have the other one to do is the daily demand, annual demand divided by the days of the year. The days of the year are 365 days. So you got 43.8 bottles. Okay, this is what goes on. Then we have the maximum formula inventory. This is P minus D multiplied by Q over P. So finding the value of Q, our Q was 1,750 bottles. So after finding the 1,750 bottles, we had now to find the total stocking cost. So this is total stocking cost. Okay, the TSC is total stocking cost at Q of 1,750. So total stocking cost, substituting this Q value, given the P and the D that we have already calculated here above, we are getting the total stocking cost, okay, of that is 11,089.29. This is using these computed values, substituting here. We have gotten the answer here. Okay, so this is 11,089.29. Now, there is a consideration by management. There's an option by management of increasing the capacity, okay, to 3,000 bottles. Would that be a good option in terms of cost saving, the quantitative? So we need to find what will be the total stocking cost when we increase the maximum capacity to 3,000. So increasing capacity to 3,000, we are finding using the maximum inventory level formula, we are getting down to our value of Q in this case is giving 6993.9. That is substituting in this equation. This is P, and then this is D, the steady demand. This is maximum inventory. Then after this one here, we are getting the value of Q as 6993.9 bottles. So after getting these bottles, we are supposed to see the savings from the 11,089.29 and minus this one, we are getting the savings of how much? The savings of 4,095.39. So this would be okay. So they can go to maximum. This will increase. Okay, so management should increase the storage to 3,000 bottles. Increase storage to 3,000 bottles, because that would have been a cost saving. Okay, well, that answers question 1A. Okay, so now getting down to question 1B, already we have actually concluded that you need to increase okay, storage to 3,000. Now, what would be an optimal production policy for the winery? How does the optimal production compare to the initial idea of expanding storage to the maximum 30,000 bottles in terms of cost saving? What action should management take to implement the optimal production policy when compared to the current policy of producing the wine until the storage is full? Okay, so when getting down to this one, we actually now decide to use the economic lot size, which is the economic production size. So for this economic production size, we could simply say 2ds over c multiplied by p over p minus d. So after substituting the values that we have already calculated, we found an economic lot size of 5,463. All right. So this one that we have found, we now need to substitute this as a Q in our total stocking cost. So Q over 2, P minus D over P by C plus D over Q on S. So this is annual setup. Okay. So we have this one as annual setup, cost. All right. So this is annual setup cost and annual holding cost. And after finding out these ones, we have found the total stocking cost of 6,443.74. Now, compared to the current storage of 750 bottles, we have the savings of for 750 bottles, the total stocking cost was actually at 11,089.29. So as we move to the economic load size, in this case, as we get to the economic load size, we are able to see that we have the 6,443 total stocking cost compared to the one that we found earlier of 11,089.29. So on this one, we are now simply looking at the difference, and our difference here is now coming to the savings of 4,645. That is our savings. And the savings that we have found here is higher than the savings of 4,095.39 that we found earlier here, meaning that management should use economic load size than current storage of 750 bottles, because the cost saving will be higher if we are to migrate or if you are to use the economic production size. The P is our daily production.
Sorry, Mr. Sam. Hello?
Yes,
Hello?
please. Okay, so in this question one of the assignment, we are looking at the question one. Question one is on inventory management. Okay, and what goes on in inventory management is that we we look at the advantages of keeping stock. Also, we look at the inventory models. So for the sake of this question one, says Dream Resorts makes wine. So they are producing, which it bottles and sells in its own location, the restaurant and wine shop. It costs 1,100 to set up, then brew and bottle a batch of the wine. The annual cost to store the wine is 2.75 per bottle. The annual demand for the wine is 16,000 bottles. That's annual demand. And the winery has a capacity to produce 28,000 bottles annually. Then the current production policy is to continue producing the wine until the storage gets full, so they are in production. So in production, we call that one as model 2 of inventory. Okay. And the storage holds a maximum of 750 bottles of wine. Production starts again when the inventory of the wine is depleted. Assume 1 year, 365 days. Okay. Now, the owner of Dream Resorts are considering an option of increasing the wine storage space to hold a maximum of 3,000 bottles as part of their expansion strategy for the next 5 years. Is this a good option in terms of cost saving, be quantitative? So the information that we have here, we need to analyze that information. So as we get down to the solution for question 1A, we, okay, we are simply saying days of the year that's 365. So this information is coming from the analysis for question one. The days of the year are 365 days. D is annual demand. So this capital D is annual demand. That is given in the question. And then this P is also annual production. And this is C is the carrying cost or holding cost per unit per year. C is our carrying cost or holding cost per unit per year. And S is our setup cost. So the current production policy storage of 750 bottles maximum, according to the question that they have given us, we are simply saying 750, according to the storage currently, 750 bottles of wine. So we need now to find out using the formula for maximum inventory. This is the formula for maximum inventory, which is given by P minus D multiplied by Q over P. Okay. So Our ELS simply means economic load size. And what we are simply doing now here is that we need to find the value of Q. This 750 was just the maximum inventory storage capacity. So we need to find the value of Q using the formula for maximum inventory level, which is this one. All right. So from here, after we subtract and foremost, we find our P is our daily. This is a small p, this P. This is our daily demand and daily production. So daily production, annual production over days of the year. So we had 28,000 annually, annual production, 28,000 divided by the days of the year, 365. And our daily demand is annual demand divided by days of the year. So annual demand is 16,000 divided by 365, which is giving us 3.8. And then our daily production is 76.7. So after getting this, substituting in the maximum inventory formula, which is above here, to find the value of Q, is giving us our Q of, after making the substitute formula, solving this, and the multiplying, cross multiplying here, we are getting our Q as approximately 1,750 bottles. After finding this 1,750 bottles, there is need now to find the total stocking cost. The formula total stocking cost is given by, okay. So the total stocking cost is giving us 11,089.29. That's the total stocking cost, okay, for a maximum storage capacity of 750 bottles. Our total stocking cost is given us the 11,089.29. All right. So now there is a concern that management, they are now saying the owner of Dream Resorts are considering an option of increasing the wine storage space to hold a maximum of 3,000 bottles as part of their expansion strategy for the new 5 years. So let us see if that will be viable. So if you are to increase the maximum storage to 3,000 using the maximum inventory level equation, substituting it, we are getting now our value of Q. Yes, from the 750 maximum storage to 3,000 maximum storage, substituting here to find the Q. Okay, our Q is actually, so our Q, is it so on?